So in this video, we're going to look at our period 3 oxides and how they react with water. So let's just remind ourselves of period 3. We had our oxides were sodium oxide, magnesium oxide, and aluminium oxide. Then we had the silicon dioxide, and as we went across, then we had phosphorus 5 oxide, and sulfur dioxide, sulfur trioxide, and then remembering that chlorine and argon didn't form oxides. Remembering that we've got a bit of a split here between the metallic and the covalent. So the metallic forming ionic oxides and those non-metal ones forming covalent oxides. So let's split it up and let's take each side first. So let's look at the metallic oxides first. So remembering that our metallic oxides are ionic structures. So let's actually rub that out. Let's call them giant ionic, which means electrostatic force of attraction between oppositely charged ions, but they have ions in the lattice. Okay, so we've got these ions, these oxide ions that are in our structure, and they're going to react with the water. So remember, we're doing reactions with water here, and they're going to form hydroxide ions. Okay, so sodium oxide, when we put the counter ion in the sodium, then we will be able to see what happens to it. We're going to react it with water, remembering that we're making hydroxides. So sodium's a 1 plus and hydroxide's a 1 minus. So sodium hydroxide should be a formula we're fairly familiar with. And if we balance that equation out, put 2 here. If we want to, we could put state symbols. Solid oxide, that's a white solid oxide. And we're going to make a solution of sodium hydroxide. Sodium hydroxide is a strong alkali. It fully dissociates, fully ionizes in water. So we're going to look at very high pHs. Questions are going to give you hints. It formed a solution with a high pH. That's going to give you a clue. It reacted vigorously. Magnesium oxide. If we take magnesium oxide and we react it with water, remember we're going to make the hydroxide, but the hydroxide of magnesium is magnesium hydroxide. Remember that formula's got, because magnesium is 2 plus, we've got 2 hydroxide ions. But remember that this is sparingly soluble. That means it only dissolves a tiny bit, which means that actually a lot of the magnesium hydroxide stays as a solid and only a small bit of it goes into solution. And as a result of that, the pH of the solution is kind of much less alkaline and only just alkaline, 8 to 10, because it's sparingly soluble. Then we've got aluminium oxide, and if you remember from the beginning video, we said one of the reasons aluminium doesn't react with water is because it has an aluminium oxide layer which is insoluble in water. When we come to talk about aluminium oxide later on, we're going to find out that aluminium oxide is something called amphoteric, and amphoteric means it can react with acids and bases, or it can act as an acid or a base. But that's because aluminium oxide is ionic, but has some covalent character. So although it is an ionic metallic oxide, it has some characteristics of being covalent. So it can act as a base because it's ionic. Okay, but because it has some covalent character, or it can, so as well as, so it can act as a base, maybe I should say and an acid, because the covalent oxides act as acids. So it can do either. So in general, period 3 oxides are, the ionic period 3 oxides are bases. So the oxide ion is an ion. It's there. In the metallic oxides, there is an actual oxide ion, whereas in the covalent oxides, there is no ion because it's joined covalently. But in the oxides, then you're going to form these hydroxides. In the metallic oxides, you're going to form these hydroxide ions, and so they're basic. They can accept protons. Aluminium oxide is a bit different. It is ionic, so it can act as a base in this way, but it has some covalent characters, so it can also act as an acid. this equals a special word we're going to come across later called amphoteric. So there are our metallic oxides forming hydroxides, then being basic. And then we've got our non-metal oxides. So if we go back up to the top there, we can see that's SiO2, P4O10, and the two sulfur oxides, sulfur di and sulfur trioxide. And in general, they form solutions containing H plus ions, so they're acidic. And let's actually put here, let's put what we put before, they are covalent structures, and the covalent ones are acidic. So there's these clue words in questions. The ionic ones are bases, and the covalent ones are acid. Now SiO2 is macromolecular, and so it's insoluble in water like diamonds are. There's too many strong covalent bonds to break. P4O10 though, let's have a look. So P4O10, our covalent oxide, is going to react with water and it's going to form an acid. So what's the acid that contains phosphorus? We've got phosphoric acid, H3PO4. We have to remember that formula. Now we need to balance that equation. So pause the video and balance that equation. And if you've done that, you should have put a 6 here because of the 4 phosphoruses. You had to put a 4 in front of here. So this is our equation. Phosphoric acid is a strong acid, so we're going to get a pH of 0 to 2. It's a strong acid. If you were asked to give an ionic equation for this reaction, P4O10 is covalent, water is covalent, but phosphoric acid is a strong acid, and so we could say we would get 12 H pluses and 4 phosphate ions. So we'd be being tested on our knowledge of the ions there. Right. Sulfur dioxide. So sulfur dioxide reacts with water. Now you might remember this equation. We did look at something similar in the group 2 pack. It's actually going to form a fairly weak acid, so I'm going to use a reversible arrow because it's going to form H2SO3, which is called sulfuric 4 acid. So have a think, why 4? Pause the video, maybe have a think. And if you've had a think, it's because each of the oxygens is -2 and each of the hydrogens is +1. Now if you do the oxidation states, you'll find that the sulfur in that sulfuric acid is +4, so that's often called sulfuric acid, sulfuric 4 acid. If I do that equation ionically, sulfur dioxide is covalent, water is covalent. This one's reversible because it's a weak acid, so not fully ionized. Forms hydrogen ions, it's partially ionized, and hydrogen sulfate ions. And because it's a weak acid, we're not going to look at a pH of 0 to 2. We're going to probably look at a pH more like 2 to 3. The equilibrium lies to the left. There's not many hydrogen ions in solution. And then our last one, sulfur trioxide reacting with water. It's going to make our usual sulfuric acid, which we might call sulfuric 6 acid. And that's a strong acid as well. So we're looking at pH 0 to 2. If we did an ionic equation for that, SO3 plus H2O, then we're going to get fully ionized. So we're going to get sulfate ions and hydrogen ions. And we can say in general, the covalent oxides are acidic. So we've got protons being donated.